Hello, this is Tlaloc Venancio, and today I will be presenting effective instruction in a math classroom. The last 3 months I have been at Crawford High School as a student teacher, and I have grown and learned a lot, and I'm happy that I have been able to implement a lot of strategies that I have learned in both my methods course and education classes. So I want to start with instruction in math and how good math instruction happens. Uh, I want to start with saying that there's a big name out there. His name is Dan Myers, and he asked all math teachers to create an entry point to all the students. So I created this game for my students that is pretty well known, but I didn't have the resources to buy them all. They're about $20 to $25 online. The cheap ones are cheaper, but they also break easier. So I decided to go to Home Depot, and in about 6 hours, I created about 30 of these towers of Hanoi with some tools that I borrowed from my relatives. And Dan Meyer talks about a three acts kind of role play in a math classroom. Act one is introducing the conflict or the problem clearly, visually, viscerally, and with few words. And it should strike curiosity to all students, no matter the walks of life. So you want to create an inclusive math classroom. So for example, in this game, these are called disc, these little things right here, and the sticks are called towers. And the goal of the game is to move the disc from biggest to smaller, just kind of like it is here, from the first tower to the last tower in the least possible number of moves. And then there's two rules. One rule is that you can only move this one disc at a time, and that you cannot place a bigger disc on top of a smaller disc. So that's how I started that math lesson, and as you can tell, all students are kind of like in it because they're playing a game. And I started with 3 discs, and then I gave them a graphic organizer to record their moves. And then after I kind of noticed that the class was on 4 discs, I stopped the class and I said, okay, what is the least possible number of moves um, that they require for 3 discs? And for example, if a student had that their least possible number of moves was 9, the real answer is 7 for 3 discs, then they will go back and try to figure out to see how they could get 7. So that created a curiosity, and then it gave us students a sense of like ownership in the math. And then after I noticed that the class was done with 5 discs, a lot of students kept playing. But then on Act 2, students overcome the obstacles, they look for resources and develop tools. The goal of the game of that day was for them to create a formula that would give them the least possible number of discs the least possible number of moves with any number of discs. So in Act 2, what I gave them that n was the number of discs, and f to the n was the least possible number of moves. And through it, students were able to solve and create 2 formulas. They came up with the recursive formula and the explicit formula. And so then that fulfilled Act 3, which means that they resolved the conflict and they set up an extension or a sequel. So then I asked them with their formulas, what is the least possible number of moves for 10 discs? And students were able to solve it. Now, some of them took a little bit longer with the recursive formula, and then the ones with the explicit formula, they realized that it was a lot easier for them to figure it out. Now, this also helped develop, and help me kind of implement being culturally sensitive, because this game could have been done on a phone, but I did not want to assume that everybody had a phone. So we don't want to assume that all the students have the same resources. So it's better if we provide this. The other thing with the computer and electronics is that everything I found online kept count of their number of moves, and I thought it would be better if they did it in their head, again, giving them that empowerment. And then with this lesson and how math lessons need to be sequenced, I showed incorrect word with good mathematics, good mathematical ideas, and I asked the class, what is it about this equation that I really love? What are the good math ideas? Instead of saying, why is this wrong? And then I went from mechanical to abstract, and a lot of times the mechanical has the right answer, but then it's better. It's good to finish with the abstract math when you sequence a lesson, because even though the mechanical processes have the right answer, the abstract really teaches students to think outside the box. And again, by showing incorrect work with good mathematical ideas, I elevated the status of a lot of the struggling students who more or less were about the same level and had the same ideas. And then it allowed me to share different approaches to the problem. And this is from orchestrating discussions in a reading we did for my methods course. With academic language, with interpret, I train students to to ask clarifying questions to peers. For example, when they were working together in groups to figure out the formula, students were, asking clarifying questions to their peers about why they had chosen a certain formula. And then also when I was giving instructions, I had them do a pair chair where each one of the pairs would tell each other what the instructions were. With describing, students need to think and talk like experts in a classroom. So there's a warm-up activity I have done in the past, which one doesn't belong, and that one gets them talking like experts because I use a lot of mathematical ideas. And with the Towers of Hanoi, after they discover the formula in a later lesson, they were talking about, was this a recursive formula, was it an explicit formula, and what is the sequence? And then at the end of that lesson, I asked students to reflect on it and to do a write-up on what they learned about the Towers of Hanoi and the math behind it. So it's kind of like the academic language that I utilize during that lesson, and the academic language that needs to be utilized in most math lessons. With differentiating instructions and scaffolding, I have done a lot of graphic organizers for my students. And the way I do it is I give it to all the students. And for example, in this graphic organizer right here, completing the square, I left a blank, and then I gave the students, the standard form to completing the square. And then I noticed that some students did not need this at all, but the struggling students did need it. And I noticed that a lot of them were using it to complete the square. And it was really cool to see how they left, that graphic organizer, and then started doing the math in their own heads. Some other activities are topic sentence supported by other sentences, a model sentence. For example, when we did the which one doesn't belong, I gave them a sentence started that said, the one in quadrant 1 doesn't belong because, the one in quadrant 2 doesn't belong because. So that's the way to kind of like differentiate instruction and scaffold in math. With the EdTPA central focus in math, they want us to really hit 3 key items: the conceptual understanding, the procedural fluency, and the mathematical reasoning. So with conceptual understanding, they want students to understand more than just facts, to see the math that is around. For example, with the Towers of Hanoi, they understood that there was a recursive and explicit formula that would help them figure out the least possible number of moves with any number of disks. With procedural fluency, the ability to be accurate, efficient, and flexible. So are they able to use that formula and find the 64 with 64 disks? How many moves would it take, or the least possible number of moves? And then for students to be able to do mental math, it's another example of procedural fluency. With mathematical reasoning, we want students to think logically about the relationship among concepts and situations. For example, how do we translate what we learn with the Towers of Hanoi to math in business and interest rates, math in nature with photosynthesis, and what about fractions, and math in cooking, how can we reason with not just what we learn in a classroom? Thank you for listening to my presentation.